This video is to address some questions regarding how to do this sample problem, which was something I uploaded last week. Now, to begin with, you guys should understand I will not give you a question like this on the test. I'm answering the question because somebody asked, but this is not purely a programming problem, right? This is more of a logical, conceptual thinking problem, and some people enjoy thinking about math and number challenges and puzzles. So we're going to talk about how to solve this. But just to set everybody's mind at ease, you're not going to get a question anything like this on the test. Just relax. Don't send me panic emails. Your test is going to be simple for loops, while loops, if then, write an object, write a method, just those 5 things. But because somebody asked here, let's talk about it. So to begin with, whenever this is math, right? This is like a pure mathematics problem. And if you enjoy solving math problems, you probably already have some ways in your mind of how you approach stuff like this. So the way you always do it here is they say you have some number. Well, how do you deal with a problem where you told you have some number? Because here you're writing a method, right? So this is the method up here, and you have some number. So you just make up a number, any number, grab a number out of thin air. 4. Let's say that number is 4. Why is 4? I don't know. If that bothers you, then go with 5 or something. So just make up any random number and stick it in there. Oh, that looks like an S, not a 5, doesn't it? So we'll put 4 in there. And then we'll solve the problem as if this was 4. So here we have our method, right? So we say a public, so that's just the visibility modifier, and it's a method which is returning some integral value, and it's called mystery, and we're passing in a parameter of n. What is n? Jesus, people, pay attention. You got to listen to me. I just told you it's 4. Just make up some number here. So we now have a parametric method. We now have a method, and you could write a little public class with public static void main, and you could create an object, and you could call that method, or you could make that public static int, and then you could just call it directly from main. I would do it for you, but I've got a bunch of stuff. I have to get some tests up and set up today, so I'll go over this together in our class on Saturday if anybody wants to see it. But you can do it by yourself. I think you should be able to. And now what do you have right here? You have a for loop. And we're saying for k equals 0, right? So we have a loop. It's k equals 0. How long is k going to go? Well, numList is an array. You see up there, we created an array called numList. And they're giving us here as a precondition. They're saying numList contains a list of int values in no particular order. Make something up and solve the problem. Just make up an array. Like I'm going to do it for you. Watch here. So the basic problem is you guys overthink things and you look for reasons to get worried about stuff. If you just sort of relaxed and just played with a little bit, you'd be much further ahead, believe me. So here's some array that I'm making up. And how long is my array going to be? Well, it's not specified. So let's make an array of 5 values. If you don't like 5, then make it 6. It doesn't matter. So here we have, I want an array of 5 values. Or some other number if that doesn't make you happy. So here's my first value, second, third, fourth, and fifth. Now remember over here, arrays are always 0-based indexing. So that means that this is going to be the 0th element. And that will be the first element because arrays are 0-based. Whoops, 1. And that will be 2, 3, and 4. So I now have an array of 5 elements, and the indices of the array are 0, 1, 2, 3, and 4. And now you just work the problem, right? And I've actually just hand sketched something out over here. So look here now. So here's my array. So I've made an array, and that is my num list array, and it's 0th, 1st, 2nd, 3rd, and 4th position, and I just randomly put some numbers in there. I closed my eyes and I made up some numbers. And now I have to invoke this method called mystery, and I'm going to suppose that 5 in this case is my input to that parameter, and my k value in this loop is going to go from 0 to 4 because that's the number of entries in the array. And then I just say here, I made a little table. So I said if k is 0 and n is 5, so what is the value of my array at index 0? Well, it's 4. So then I say, is 5 less than 4? No, I don't think so. I think 5 is greater than 4 usually, at least today. So that's not happening. And then we get to k is 1. And what is the value of the number in array position 1? Well, it's 9. Is 5 less than 9? And the answer is yes. Now look here at the logic of this, of the way this is written. So it's saying that if n, meaning n is the value we pass in, is less than or equal to whatever value was in the array, when we happen to access that part of it, then we're out of there. We bail out, we return, we don't even do anything else. We just say goodbye, I'm leaving. Now we have a catch-all case down here, because if you didn't put this, your code wouldn't compile. You'd get an error and say like unreachable statement. But try it if you don't believe me. We'll demonstrate it in class on Saturday. But if for some reason I walk through this entire loop and I never encountered this condition because there just didn't happen to be a value in my array which n would be less than or equal to whatever value coincidentally, accidentally happened to be in the array at that position, I would never hit that return. So then I would just bail out and I would just return the length of the array. So that's what's going on there now. So the way you do this, student who asked the question, sorry, I can't remember the name, but some student just, I saw an email and I'm answering it for them. So you do this, so you make a little truth table, so you iterate, so you say you're iterating over your for loop, so k is 0, 1, 2, 3, 4, and then you know your value of n because you set it, and then you just ask yourself the question. So in this case, the answer is yes. So this is where it will bail out of the loop up here, right? It'll bail out of the loop, and then you say which of these things is true. So the greatest value in num list is at index j. Well, just go and do your own experiment and find out about that. The greatest value in the array is at index j, and j just happens to be wherever we are in our for loop at the moment. And no, I don't see anything in the logic that would indicate that that's true, so I don't think so. The greatest value in num list is less than number. The greatest value in num list that is less than number is at index j, and again, I don't see anything in the. Now you have to be careful here because some of these things might be true sometimes, and I think this is kind of a this is a very abstract question, right? Because what they're encouraging you to do here is think deeply about the memory model of how data values are stored in an array. And so a lot of these things could be true or false depending on which numbers you happen to put into your array. And now here they're saying all values in num list from index 0 to j minus 1 are greater than or equal to number. And again, I don't think so. I don't see how the algorithm would support doing that. All values in num list from index 0 to j minus 1 are less than number. Well, think about that one now, and I'm going to encourage you, if you're really interested in this, go and enter in this code, make up some numbers, and experiment with the code by yourself. But what you're going to have to pay attention to is what's going on with this if statement. If n, which is the value we passed in as a parameter to our method call up here, if it's less than or equal to the number we encounter in our array, then we return. So all values from 0 to before the point where we encounter that number are less than number, and I would say yes, because if we encounter that condition, and there's no guarantee that we will because we don't know what's in our array, but if we did, then condition D would be true. So if I had to answer this on a test, I would choose condition D. Having said that, I would not ask this on a test. I mean, maybe this is like a very advanced theoretical information science. Basically, what this question is testing is your ability to work with the memory model, which I might get to later on. I might give it as an enrichment assignment for some of my advanced students, because I know a lot of students in the class are just sort of new to programming, and if I gave you something like this, you'd freak out, like your brain cells would just fry. But I know I have a couple of advanced students in the class who perhaps want to learn about the memory model. And if you guys want that, I'll leave it to you. You ask me about it and I'll answer your question. But I don't think I'm going to bring the memory model into an introductory programming course. And that's what this is asking about here. So I would say the most reasonably likely answer to be true is D. But you write the code and you do your own experimenting if you want to know about this. And then the option E, all values in our array called numList from index J to the end of the array are greater than number. And we don't know that. See, here's something you have to be aware of. What we do know is that at the point where we bail out of the method, right? Because when you hit return, you don't just bail out of this loop. You bail out of the entire method and you go back to your calling point. We know that if that happens, we encountered a condition where our input number n was less than or equal to whatever value was being held onto in the array at that point. So we know that that's going to happen. But E, all values in numList from J to the end of the array are greater than number. How would we possibly know that? Like, this is actually a very philosophical question. This is a classical problem in computer science that was developed in 1954 called the Goldbach conjecture. Try that again, Peter. The Goldbach conjecture, and it talks about what is theoretically possible to know in a computer science context and what is impossible to know. And Goldbach's conjecture is complicated. My daughter Nikki is she's working on a partial solution for her PhD. So people are still, philosophically, that's a very kind of important question to us as human beings. In principle, is it possible for us to know everything that's going on in the universe? And Goldbach's conjecture says no, it's not possible, even in principle. Not because we're not smart enough, he says, that because of the structure of mathematical reality, it's not, well, I don't want to go to, it's not traversable. They're saying that that a space of data points is not traversable, meaning you have no guaranteed method to get from one point to any other point. You might, sometimes by luck, you might be able to traverse a mathematical space, but there's no guarantee that you can. And that's sort of what they're getting to here in point E. They're saying all values in the array. Maybe the array is 100 million long. Maybe it's 1 billion long. Maybe there's more entries in the array than the number of atoms in the universe, right? Because nobody is telling us anything except the array, except that it's a list of numbers in no order. And the natural number set is infinite. There's no maximum number. So E is stating that given an infinitely long, potentially infinitely long array, that there, from index J to the end of the array, all values are greater than number. We don't know that. They might be, they might not be. But the thing is, we're never even going to get there in this program, because as soon as we hit this line right here, the if statement, we bail out of the program anyway. So we're never even going to touch those numbers to see them. So not only do we have no way of knowing whether they're greater or less than or anything else, we don't even have a way to reach them in the algorithm space of this program. Anyway, I hope this answer was a little bit interesting for you. And my suggestion, if you're curious about this, just write the code and drop in any random numbers you like and play with it and experiment. And I will go over it in class if anybody has interest. You will not be asked about this in test. For the sake of the test, just write some simple programs involving for loops, while loops, if then. You should be able to write an object and put a method call on it. And there's a lot of really nice practice programs here at my favorite website in the whole world, almost, which is W3 Schools. Oops, I don't have a web browser open, do I? All right, so let's go to W3 Schools. And there's some stuff here on Java. There you go. So I would just go through some of these exercises. I think they're quite interesting. So w3schools.com/Java. Now I've set up a Slack team room for our class, and I'm going to send out the link to that as well. And I'm going to put some of our study resources right here. So study resources for upcoming test. And another one I like is Java Tutorials Point. Is it Java Tutorials Point? I think it is .com. I mean, there's tons of stuff out there. You can just go and Google. There's like a million of them. Tutorials Point. There we go. I mean, anyone you like is good, but there's another one down there as well. But if you're looking for more programming practice problems, I think that website is pretty good. And you can just jump into there. And the thing is, do not read the code like you're trying to read a book or something. Actually enter in the code and practice running it. So, yeah, so there's like a little sample problem you can get going on. So just write code and you'll be fine. All right, guys, thank you for the question, student who asked me this. It's nice for me to get a little bit philosophical sometimes, because the fun of programming is to contemplate the mysteries of the universe. And sometimes just day after day of teaching people how to write for loops, it grinds my poor brain cells down. So I appreciate you let me exercise my my little philosophical bent. And if you have any more questions, you can drop them in the Slack room as well. That's probably the fastest way to be in touch with me. So the way the Slack room works over here is I'm going to send you a link, and you can jump in there and you can look for the channel Java Programming. Now I'm bringing a number of my other courses into here as well, and I'm just going to keep one Slack room for everybody because it's too much confusion for my poor brain to try and manage multiple different if I you know, because each one has to be with a different email address and stuff. So you might see people here that you don't know. They might be from my other classes. They might be from other schools. And if you're curious to see some of the other stuff we're talking about here, you have my welcome and my encouragement to go and look at it. But your stuff is going to be in Java programming. So that's about it. That's all I have to tell you right now. And yeah, so bye and have a nice day. And we'll see you on tomorrow. We'll see you on Saturday for our class. Bye-bye.